So when I got this email from Dan, which is a lie, I think Peter got the email from Dan and then he forwarded it to me, or maybe I got it when I was on vacation so I didn't read it, but then Peter forwarded it to me. I saw that there was a talk about a way to protect secrets. And I think there is a truism in DevOps, and it's the same as the truism in web application development. If you're in web app development, the truism is every day there's another JS framework that is launched on GitHub. In the DevOps world, every day there's another vault that will allow you to protect secrets. And so it's awesome that we get to hear about one of them tonight. I'm going to let Dan talk about Ansible vaults. Sweet. Thanks, Dan.
As Nathan pointed out, I realize that I now have the very unenviable position of being between you and seeing your loved ones. So, I will do my very best to make this relatively short. Who here has ever worked on an open source project? Raise your hand. Cool. Fair number of us, right? This should be very relevant to us. But a little bit first about me. You guys probably don't know me. I am Dan Davis. It was on the meeting invite, so that's great. I've been a software developer for about 8 years now, and fun fact about myself, I just got back from the beach. Not that beach. If you guys have not seen it, there is a... Yes, it's really cool. This is the National Building Museum. There's a giant art installation called The Beach, and what they've done is they basically filled this thing with like thousands of those little plastic balls that you find at like Chuck E. Cheese, but they're all sand colored. So it's basically just a giant ball pit that you can hang out. That's what it looks like from above. It is insane. It is so much fun, and there's a bar at the end, so you can drink. Best experience ever. I highly recommend it. This is me jumping into the ball pit. So I mean, it was really, so if you have not seen this, it's going through September. I would go really soon because that ball pit is going to get super gross. You don't want to be there in September, I assure you. So,
where is it?
This is at the National Building Museum in downtown DC. So, it's near Chinatown. Yeah. Okay. Anyways, but seriously, a little more about me. I came from the Java world. And I've been doing Python development for about 2 years now, so definitely in the Python space. I've also been doing a lot of DevOps work recently, so lots of automation, quality, sort of, everybody seems to need those types of skills. And I've been doing a lot more work with open source. So I started seeing this, I think the last 10 years or so, we've had two really, really important things happen in our industry. Question?
What made you decide to switch from Java to
opportunities. So, there was the project that I was on was rolling off. I also knew Python. I knew both of those languages, and the next engagement that I was on just came up as Python. So, I actually really enjoy working in Python, and secretly, I probably will never go back. It's just a much more pleasant experience. So, but there are these sort of trends that I've been seeing the last maybe 10 years or so. There's two of them. You've got, on one hand, open source. Open source is not a new concept, but it's really gained a lot of traction in the last 10 years or so. This is thanks in part mostly to things like, GitHub and social coding, that sort of thing. So like Bitbucket, GitHub, all those services that allow you to have something that allow you to host the code, and it's out in the open for you. So before we didn't have anything like that. So the other thing that's really been interesting is servers in the cloud. So basically like cheap infrastructure. So the idea that I can have servers that we just stand up and that are just, we can pull them down from anywhere. It doesn't matter, it doesn't cost us much to put that together. That's really awesome. And that has been really spurred on by configuration management tools like Chef, Tup, and Ansible. So that's great, and now Docker and SaltStack and other tools like that too. So when you think about these two things, sort of like open source and cheap infrastructure, you might say like, well, that's a really cool natural fit, right? Like we want those things to fit, those things go well together. And that's the whole idea behind like infrastructure as code. So I basically have, things that describe my source code, things that describe my infrastructure, and I write those things down into code, and then I commit them into something like GitHub. Now all that stuff is open source. It's great because it's accessible to other people. So in yesteryear, we used to have to, say, well, this is my infrastructure, I'm going to stand it up, and if you want to use it, I have to, allow for that. I have to sort of think about that stuff. I have to, plan for it. Now I can just say, like, you stand it up on your own infrastructure. You figure it out, I'll tell you how to do this. But, I'll give it to you, the instructions for standing that up. So that's nice. It's also auditable. So if I wanted to go in and I said, how have my servers changed? How's my configuration changed recently? We can look at that. We can see who changed it. We can see why they changed it, and we can ask questions about it. That's really awesome. So there's a lot of benefits to that. This is a really good thing, having our infrastructure out in the open. But there's also sort of a darker side. That darker side we're going to call DevOps. No, I'm sorry. I mispronounced that. That should be DevOps. Does anyone here know what DevOps is? DevOps is that moment of shame when you commit something that you really should not have. Something like your personal access tokens or your private keys or things like that. You commit those out in the open and everyone can see them. That never happens, but it happens. This is actually such a pervasive problem in GitHub that GitHub will now automatically revoke your personal access tokens if it detects that you've committed them. So it's a problem. So, like, why? Well, hackers apparently, or what Google Images thinks a hacker looks like. It's kind of a silly question, like why shouldn't we have our passwords out there? But it's because we don't want to make it easy for hackers to do that work. If they were able to get our passwords and things like that, they would do all kinds of bad things to our servers. They'd own them. They'd mess up the servers. They have access to it. That's like leaving your house unlocked. So this creates kind of a security paradox for us, right? On one hand, we can't really commit some kinds of data. Things like our passwords, our API keys, our personal tokens, private keys, that sort of stuff. But in order to provision our software, or to provision our servers, we need that stuff. Like, that's really critical stuff, and we can't provision them without that. So how can we be both open source and have infrastructure as code? Well, that's what I want to talk about tonight. Okay? So before I kind of talk about that, I do need to give a little bit of an intro to this, just so that we're all on the same page about terminology. Who has used Ansible before in the room? Show hands? Cool. This isn't meant to be like, you won't walk out if you're an expert, but hopefully this will get us all on the same page. So this is the 1-minute intro. Ansible works like this. You have an inventory file. The inventory file basically describes groups of servers for you. So I might group them by having like a dev, staging, and production servers. Does that make sense? We keep those groups that way. Then we take those groups of servers and we apply them to a playbook. A playbook basically says, given a group of servers, what do I want to do to it? Inside of that I have roles. So I might break those roles up and there'd be logical groupings of things. So installing Apache or Elasticsearch or a Postgres database, something like that. Those roles can be further broken down into something like a task. So a task just being a command that I want to execute on that server. Does this make sense? Okay. Another piece of this is that we have these things called group vars. The idea is that just like we can have groups of servers, we can also assign variables that are specific to those groups. So I have I might have.
Sorry, time's up.
I know. That's the applause symbol, right? No. Okay. So I may have different groups, and those groups will have different variables associated. So the production password for the database might be different from the one I have in my dev environment. So this makes sense, right? And obviously we can do templating just like you've ever done in, if you've ever done configuration management, there's templating available. So that's how we apply these variables in. We're really going to primarily focus on this stuff just because that's mainly where all of our secrets will be held, right? This is where we would put our passwords and our other secret information. So, now let's talk about Ansible Vault. How do we install it? Good news. If you have Ansible, it's already there. It comes as part of it. It can be installed with pip, homebrew, apt-get, yum. It's available on Windows now. Like, there's just all kinds of stuff. There's all kinds of ways to install it. It's available. How do we protect the data? So the idea is with Ansible Vault, we're going to encrypt the file. So one of those group vars files, we're going to encrypt them. It's using AES 256 encryption, which is sort of our industry standard encryption. It's last I read about it, it was good enough for top secret encryption. So it's solid, modern, works well. Ansible will decrypt this stuff at runtime. So you have your encrypted file, Ansible runs through and decrypts it when we're trying to apply the playbook. And that allows us to then safely store those values in GitHub. So by having those files, those values encrypted, I can store it in GitHub safely. How do I do this? It's very simple. Ansible Vault is the command, encrypt, and then your file. That's it. It will prompt you for a password. You type in your password twice. Now your file is encrypted. So I can have a file like this, which has lots of data in it, and it will turn into a file like this.
Can you go back one slide?
Yes, please.
I pulled up.
Yeah, I know. I already thought about that. Your super secret password, right? Nice try, guys. Okay, so that's what that file will look like. It's now encrypted. There's also, so the idea is if I want to run the playbook, all I have to do is I have to add on --ask vault pass. So this is the standard way to run a playbook. We give an inventory file, we give it a playbook name, and then we have a vault password that we prompted. So if you run it, it will ask you for the password, decrypts the file, everything fills in. Does that make sense? Okay. Other commands that might be useful. Decrypt. Obviously, there's a decrypt command. Edit is really useful. If you're working with these files and you want to make a really fast change, just like I'm updating a password that got changed. You can use edit. It will temporarily open that file. It will decrypt it and open it in memory. And then you can make that edit, 1, 2 small changes, and then it will automatically re-encrypt the file. This prevents that DevOps moment where you decrypt your file and then you commit it because you didn't think to re-encrypt it. So that's great. I highly recommend that. And then rekey. So if you have people leave the organization, you want to change the passwords for all of your vaults. So that will allow you to easily change the password. So what can you encrypt? Surely it's just the group parse files, right? Well, no, it's more than that. You can do the variable files, obviously, groups or hosts. You can do inventory files, so that listing of servers, in case you want to encrypt your IP addresses, you don't want people to find those. You can encrypt your templates, in case there's something particularly sensitive in those templates that you don't want people to know about. You can encrypt your tasks if you want, so I have a set of tasks that I want to run, but I don't want people to know what those are. You can even encrypt your entire playbook. That's a lot of things. Having said that, sorry, the main limit is your imagination. Having said that, please don't encrypt everything. The rationale here is that it's counterintuitive, right? You'd say, I think that if I encrypt more things, I'm more secure, right? Like if everything is encrypted, I'm the most secure. But what happens when developers need access to change things? The more I have encrypted, the more developers will need to have access to those files, and that means I have to share that password with more and more people. So we also lose commit history, right? If I go through and I say, here's my encrypted file, and make a change to it, when I commit that, it's just going to show up as a bunch of gobbledygook. And I don't really know what's changed, and I lose the benefit of being able to see that change history. So for those reasons, the best practice here is really to only encrypt the things that are actually sensitive, the things that are actually important. But how? Right? Like we might have a group parse file that has lots of stuff in it, and some of it might be secret, some of it's not secret. How do I split that stuff out? So the way that we do this is using a feature in Ansible. If we have we can have either a group parse file, or we can have it as a directory, right? So this is really nice. It'll look in there and say, is this a file or is this a directory? So as an example, here I have a group parse file. I have dev, staging, and production. 3 files that hold my stuff. Now what we want to do is we want to split this up. I have a group parse file, and I have a dev, staging, and production folder. And then inside of that I have 2 YAML files. One for my secrets, one for my non-secrets. Non-secrets are things like directories or general templated information, that sort of thing. So does this make sense to folks, how you split this up? Okay. The one downside of doing this is you might have lots of variable fragmentation. So the idea is you're splitting things up now. It's hard to sort of see if you've included the right variables, that sort of thing. So here's an example of that. I have information about a Postgres server I'm trying to stand up. The host, the database name, the username, the port, and maybe the password. Where is that password? And you can say, well, presumably it's in the secrets file, but that's encrypted and I can't see it. So I don't know. Or maybe the developer just forgot. I don't know, so maybe I should put that in there. It's confusing. The better practice here is we can use referencing. So the idea is that instead of having just that file missing, that's a variable missing, we'll just say Postgres password, and then we'll reference something in another file. I usually like to prefix this with vault so it's explicitly clear. Looking at this, you know where it's coming from, it's very clear, it's very simple. So this is the best practice I recommend. So that's all cool and everything, but I want to address the elephant in the room here about this, right? I mentioned that in order to run this thing, it's going to prompt you for your password. That sucks. I hate that. Prompting with passwords is the worst, especially when we try and automate things. So how would we put this into something like Jenkins? Well, you know, they do have this idea of like a password file. They offer that, but the password file is not really much better, right? The idea is like instead of prompting you for the password, we'll just leave your password lying around in a clear text file. You know, and it just sits somewhere in there. It's like, oh, that's great, that's cool. That's, you know, you've done all this work to encrypt your files, and now they've just got some files sitting there that's really easily could be acquired. So a better solution is a password script. One of the nice things with Ansible is that password file can actually be an executable file. So the idea is it's just going to capture whatever is in the standard out as the output. And then it's going to use that as your password to plug into Ansible Vault. It's going to capture that so it doesn't show up on the screen. The idea is I can write a very simple script. I can even code it in Python. So all you have to do is a shebang for Python, import OS, and now I can grab that from an environment variable for Vault password. What's great about having a password script is that I can do all kinds of really cool, complex stuff because I can write it in whatever language the shell will allow, that your operating system will allow. So I can query a database, or I can make a call to a remote server. I can have some kind of I can have additional protection in place. And that's all customizable, configurable, however you want to do that. So now that we have that knowledge, let's put it into a continuous integration system. So let's toss this thing into Jenkins. Those of you guys who don't know, Jenkins is a popular CI tool. There's an option in there for injecting passwords. So the idea is that it's just a checkbox, and it will allow you to store a password securely. It masks the output. And then whenever you want to run like a script or anything like that, that will be available as an environment variable. So I can combine that with my password script. It will look for that environment variable. That environment variable is being injected in, and now we have value. The best part here is that it's being stored securely by Jenkins. So it's no longer just a file sitting somewhere, it's actually being managed by something. So this makes our deployments more secure. Developers don't need access in order to, in fact, we're able to prevent them from deploying because they can't deploy from their local development environments because it's all stored in Jenkins now. So if you don't have access to the password, you can't deploy. So the security teams really like that idea. Also, Jenkins is managing it for us. So this is nice. We have something that is built in, something that is storing the password. We can make this a global password so that all of our jobs have access to it. It provides a more consistent process. And if we ever have to rekey the file, I can change it in one place. So I'm not going through dozens of jobs that I've created trying to paste in a new password. I can just change it in one place, you're done. So I wanted to toss in some extra thoughts on security because usually when we talk about this subject, there's a lot of other thoughts. A lot of this was sort of targeted at doing this in an open source environment and putting this stuff up onto GitHub. But you might ask yourself, well, technically this could still be compromised. The reasoning being, someone can still clone your repository, take that file, and though it's encrypted, they could just crank away on it and do a brute force attack. So the challenge is anybody who can clone the file can actually attack it and do work on it. Fine, so be it. I believe that makes sense and it's within reason, although it's encrypted and it's strong. So what I recommend for that is have a private repository. The idea is that now the only people who can access that file are people who are direct owners of that repository or have access, people you've given access to. So it's up in GitHub, but at least it's hidden away in a little bit. So taking all of our encrypted files and putting them there in a separate repository. You might still say, well, okay, you put it in a private repository, but it's still, it's still technically accessible because you could have somebody who is maybe like a GitHub employee. They might have access to it, or somebody who has access to that could still technically compromise it. So really, this boils down to hosting in the cloud is still a concern. If that's a big problem for you, I recommend GitHub Enterprise. GitHub Enterprise allows you to host an instance of GitHub on your own servers. You can do whatever lockdown, security you need, that sort of thing, and it works great. The downside, it's going to cost money. So they pay for licenses, that sort of thing. Same thing with private repositories. If you want a private repository, it costs a little bit of money. But again, if this isn't a concern for your organization, then you're probably willing to throw a little bit of money at it, right? So beyond these two things, so it could be as far as on your own servers. After that, really, in my mind, kind of gets into like, conspiracy land, like tinfoil hat ending. It's like, well, what about? But it's, yeah. I think for 99% of our open source projects, all of our stuff, I think this is a very reasonable solution. There are obviously exceptions, but this should be good for most of us, and a good pattern for everyone in our community to follow. So I have the links here. This is the link to this. This is the link to this PowerPoint presentation. Thank you. And this is the link to the Ansible Vault documentation. It's very, very good, and it's easy to follow. So take a look at it if you want more information. That's all I have. Questions, you guys?
You said it runs on Windows. What does that mean exactly? Because I thought all these servers for Ansible ran on Linux.
So Ansible recently added support for Windows,
Yes.
right? So like running it on those machines. That was a big deal.
To deploy to Windows, but it's not running from Windows, right?
So it can now run on Windows. Like that's my understanding of it.
I think that's coming in 2.0. I don't think they put that on the 1.9 branch,
Okay, fair enough.
which
Okay.
is supposed to release this month, 2.0.
Something like that.
1.9 is a 2.0 release branch, I think you mean 1.8.
Interesting.
It's coming, or it's close, something like that. Anyways.
Dan, could you go back one slide so we
Yeah.
can copy down that URL?
Oh yeah, sorry. You can also Google Ansible Vault, or yeah.
I'm posting it
And-
in the meetup right now.
Oh,
Yes.
cool.
So
is there just one key that's used to encrypt the vault files, or are there distinct keys for distinct users and it's encrypted to each of them?
It's one key for each, so usually what we do is we have different environments, and we'll keep one consistent key across all the environments. And it is one distinct key. So yeah, it can be a problem in the sense that, well, I'd like to have, everybody has their own individual unique key, but that's a limitation of it right now. You also can't have, so I can't encrypt some variables or some files with one key and some files with the other key. So right now, it's just one key, but I usually like to split it up against environments, and that's usually good enough for most people's security needs. Yes, in the back.
I see that you have CCAN INI file. Can you describe the full deployment workflow, like from the moment you commit and the moment it goes to a production?
Sure. So the idea is we stood up in Jenkins, and we have the Jenkins job will check out the code for that particular repository. It's CCAN installer. It's an open source project that we stood up for CFPB. And the idea is that once it clones that stuff into the workspace, you just say, Ansible playbook. You give it the playbook you want to run against whichever environment you want to run it against. So the playbook's the same across all of our environments. You tell it which servers to run based on the inventory file, and that's usually just a parameter. It runs, and because it's and it's an agentless system, it just SSHs onto that server and does deployment. So whatever it needs to stand up, and it's just through a playbook, that sort of thing. Does that make sense?
Sure.
Okay. Does that answer your question?
Yeah.
Okay. Other questions?
So I'm not familiar enough with the Ansible universe, but I understand Ansible Tower is the commercial central, we control everything from here. Is it the same, does Ansible Tower then have that same key to unlock the secrets that it might need to push out continuously converge systems?
I assume
I'm
so.
a Tower user, so I can speak to this a
Okay.
little more.
Yeah,
So
please.
Tower has its own kind of secrets management, and one of the things that you can put in there is your vault password. And you can do that, you can have a different vault password on each set of credentials. So they've got a whole thing for setting up credentials and a few other things that you might keep secret but stored in Ansible Tower, and that's separate from Vault.
And this, this actually came up last time I gave this talk, and I want to point out for everyone, like, Tower is a commercial product that Ansible provides, but you don't need any of those functionality or features to do the things I talked about in this talk. So like, all the stuff that we talked about here is free and available, but Tower offers some nice features that like make that a lot easier to manage that stuff. So, yes, in the back.
I have an open ticket with this quarter trying to figure out how we're going to deal with our secrets throughout our company. So this is great. Thank you for.
You came to the right meetup.
Yeah, and you raised a really interesting point that I just had not thought about. It's like, how do we have sensible commit messages with this secret blob?
Mm-hmm.
Like, I imagine you can't really like enforce anything, but what are your experiences with like guidelines for what do I tell my people like about what you should say in your commit message?
We want that secrets file to be as small as humanly possible, and that secrets file should not be getting updated a lot. So it's sort of like maybe once a year, or once. I mean, obviously when you're developing, it's a little different, but that should not change frequently. So that prevents that problem. If that file is manageable and small, then we don't lose that information, and just try and make it as small as possible.
There's a whole security rat hole in that, which is in your commit message, do you say, I'm updating the database
Because Dave got fired.
Well, no, actually the first one is, do you even disclose what key might even exist in that file? Or do you just say, I mean, that's what I'm saying, there's a whole rat hole of that. So like, ask your CISO what to do with your commit messages, because they're going to have an opinion, and that's probably the only way if that's something you have to care about.
Right.
And so on the one hand, they're doing that, and on the other hand, suddenly they're emailing passwords and clear text.
But to be fair about this, like, in your non-secrets file, if we're using referencing and whatnot, it's sort of like, oh, well, I'm saying like vault, Postgres password or whatever. Mm-hmm. So it's sort of like, well, we have to have a real honest discussion about this where we say, it's reasonable to say that if I'm going to have a configuration for Postgres, it's going to include the host name, it's going to include the user that I want to use, the database name, like, that information is, it's not surprising, it's not secret, really. The value of it is, but, it's like, and again, there's different levels of paranoia you can employ. Like, if it was a really big problem, put all that stuff in the secrets file and don't worry about it, Other questions? Yes?
Since we have some chef folks here, how is chef able to handle this kind of stuff? And if they do, how is it different or same?
Yeah, sure. So there are a couple of different ways that Chef will handle encrypting your secrets. Natively within Chef, there are essentially two different ways. One is through this notion of encrypted data bags. So a data bag in Chef is basically a global key value store that any node in the ecosystem can grab data from. And it's simply key values, so it's a JSON document, you can think of it as that. And what you can do is you can have encrypted data bag values or encrypted data bag items. So an encrypted data bag item would look very much like his secrets.yaml, where you'd have a key and a value. And within Chef, in an encrypted data bag, what will get encrypted is the value. The key will stay plain text. So, and then you have a pre-shared secret. So I'm going to generate a key locally on my workstation. I'm going to distribute that key to the nodes that need to decrypt that value. The Chef server itself will never have that value to decrypt, so the Chef server can never decrypt those values, which is important because in Chef land, we have hosted Chef as an offering. You don't want me decrypting your secrets just because I work at Chef, right? You don't want me decrypting your secrets, period. Like, there's no additional qualifier required. So that's one way that you can manage that. So those data bag items can be either by default stored all in the clear in plain text, or they can be stored as encrypted data bag items. The nice thing about an encrypted data bag item or the different thing about it is that the only thing that you're encrypting are the values, so you'll still see the keys. And so on a commit, you could actually inspect the diff and see that the value for this key change. You won't be able to make sense of either value, assuming that you haven't committed your pre-shared key, which obviously would be bad, right? So don't do that. So that's one way that you can do things sort of natively to Chef. And then also, as part of the Chef development kit, which is sort of a tool set that we give you to help you develop your cookbooks, there's a thing called the Chef Vault. And what Chef Vault does is it actually will use the client key that's on the node. So in the Chef world, the way that authentication works between a node and the Chef server is you have a key for your SSH credentials, essentially. So it will use that key to say that you are allowed to decrypt this value, but you are not allowed to decrypt this value. And you can sort of manage which nodes within your infrastructure can decrypt a particular value through a thing called the Chef Vault.
And which users as well. So Nathan
Yes.
might be an admin, or actually both of us may be admins, but then if my key gets revoked, then I can't decrypt it anymore without having to really change the actual underlying value of the passwords that are being saved to the machines. But I'm also working this summer at comparing how these various encryption systems compare to HashiCorp Vault, which was released in April, which is a dedicated service from HashiCorp who bring us Vagrant and Consul and Atlas. And it's really interesting because it's a dedicated secret service system. So you can actually say, when these nodes spin up, I want each of them to be authorized to access the Postgres database with a unique username and unique password. And Vault will go ahead and go to Postgres and create those users with those grants, and then send out that username and password to the end node. And then if that particular node gets compromised, you can just revoke that particular password, and all the other nodes continue on. And then there's also a company called Conjure, which is also has a similar service, and they were commercial only, but then they felt pressure from HashiCorp Vault, so they've open sourced some of their stuff, and I'm evaluating that as well. So it's a pain in the ass, because there's like all these Vault systems, and they're really, really hard to evaluate, and any of them is better than nothing. so you know, don't give yourself a headache. I mean, you know, if you're using Ansible, start with Ansible Vault, or if you're using Chef, start with encrypted data bags, and for some CISO is shitting bricks or something, then I'll try to have a talk later on in the summer about some of these other systems.
There's also a Thycotic secret server.
Which one is that?
It's called Secret Server. It's by Thycotic, THYCOTIC.
Okay, I mean, because there's also, it's like KeyWiz.
And if I'm not mistaken,
Red October.
CoreOS, I think, also has a solution as well.
And if I'm not mistaken, one of our sponsors open sourced a key vault, a key storage system, I don't know, a couple of weeks ago.
Yeah, CredStash, it's on GitHub, it's Apache 2, and it's awesome. You'll love it.
It's called CredStash.
Actually, I want to flip you off, like, okay, great, another system.
Well, we don't have Vault in the name.
It's
so.
true, it's true. At least Google for it.
I think the point is, like, now that you all have this presentation, there's no excuse for it. Now you all know better, so that's good. So.
But there is something to be said that you might very well shoot yourself in the foot by using a system that's more complex than you're actually ready to tackle. And either by exposing stuff or by making your system unusable because you've lost access to all the secrets.
Like the main job for me, honestly, was like, I work with a lot of open source projects, and it's sort of just like, yeah, and what we really want is people to take something to a hackathon and just say like, here you go, here's a bigger box, up it, But we also want to use that same configuration for our production environments, things like that. So how can we have something that's available out in the open, but also not, not easily accessible to people? Like something that doesn't have all of our secrets online that, is terrible. So this is a good solution, but this is a solution to that problem for us.
Source Vault server, I trust it.
Yeah.
Well, the other thing I think that I think about a lot when I think about protecting these secrets, like there are so many systems, and like Peter said, you could easily shoot yourself in the foot by locking yourself out. The bigger concern that I have when I think about these things is how do I know when one of my secrets has been compromised? Do you know that today, if your secret has been compromised? And then when it is compromised, because it will be, like, how are you going to respond to that?
Well, if you buy FireEye
Yeah, you're welcome. See, you plug all the sponsors and all the designers, and I word in for them that seems like I'm being not plugging you.
I like Secret Server because you can actually use a one-time, you can use a password one time, and then after you use it against your end nodes or your host, it'll actually, Secret Server will actually go out and change all your passwords for you. So you go and check a new one out, use it, and then it'll change them as soon as you use them.
That is one of the things that I really find appealing about HashiCorp Vault, and that's really what I'm targeting for this quarter.
Yeah,
Is because I can do things like say to the developer, go at this API, and it'll give you a MySQL pass that's good for the next 24 hours. Go crazy.
Yeah.
And then I have the assurance that if they get fired next week, I'm okay.
So should we have a DC Tech Slack channel that's, should we use DevOps for this, or should we just have one that's just devoted to secrets? Hacking on secret stuff and needing to share ideas or get help. I'd rather just use the DevOps channel because I think it's harder to organize everything and not keep track of it, but let's talk. All of us.
Yeah.
Any other questions before we call it a night?
You're good.
All right, go home and see your loved ones.